Welcome to Science Time.
Science time!
You may use the following materials to perform your experiments. Ready for your mission?
What's going on?
I call magnets.
Should you run into trouble, you'll have 3 lab lines.
You need to ask the expert.
Let's take a field trip.
Guess you better visit the lab.
Something amazing happened.
Wow, that was cool.
Catch the game last night?
Uh-huh.
Coach said if I keep it up, he'll...
Do you know how long this is going to take?
Hey guys.
Hi. Fashion club was full, and my mom said I had to pick an after-school activity.
Fashion club?
What's wrong with fashion?
It's only about the least scientific thing there is.
Welcome to Science Time.
What's going on?
First timer.
What I'm about to say may shock you. Today's challenge is all about electricity.
Electricity is the flow of electrical power.
That's right. However, it is one thing to define a word, but it's quite another to truly understand how it works.
Maybe it's not too late to sign up for chess club.
Are you ready to hear your mission?
Yes!
You must answer the following questions. How does static electricity differ from current electricity? Why do electric plugs have 2 prongs? How do we conserve electricity? You may use the following materials to perform your experiments. A balloon, 2 refrigerator magnets, and a long rope. Should you run into trouble, you have 3 lab lines. Take a field trip, visit the lab, or ask the class. And remember, if you don't know a word, you can always ask Amelia. Here are your groups: James and Madison, Jaden, Robert, and Talene. Your time starts now.
The balloon is mine.
I call it magnets.
Pink's my best color. What?
Wait a minute. That's static electricity. I figured it out.
Static electricity, the electric charge that gathers on the surface of objects.
That's not the question. The question is, what's the difference between current electricity and static electricity? I know what current means. That's like the latest thing, like the current trends in fashion. I guess we better use a lab line.
Let's take a field trip. I need to change the scenery.
Hello, scientists! Need to know the difference between static and current electricity? Tyler from the Da Vinci Center is here to help you find out.
Electricity is actually the movement of electrons, which are these small, tiny particles on the outside of atoms. Static means stationary or not moving. The best example of static electricity is when you rub your feet across the floor and you get all charged up. And when you reach out to a non-charged up object, the electrons will jump from your hand to that object, giving you a small shock. Current actually means the flow of electrons. Current electricity is when electrons are flowing from one part through a wire to another part, usually to power something.
So if static electricity is the electric charge found in objects, then current electricity is the steady flow of electrons between objects.
What about these magnets? What do they have to do with electricity? I think we need a lab line.
Well, the best way to see how something works is to visit the lab.
Magnets usually have 2 poles, right? That reminds me of batteries, which also have a positive and negative end. Maybe that has something to do with the first question about electrical plugs. Let's go talk to Dr. DeLeo and see if he can help us figure it out.
So you want to know why an ordinary electric plug has 2 prongs? To answer that question, we have to look at a circuit diagram. A circuit diagram shows how the wires connect all the parts. In this case, we're going to use a battery as our source. The battery produces the electric current or electricity. The light bulb converts the electricity into light, and the switch turns the light on and off. An electrical current is a flow of electrons through a metal wire. The battery pushes these electrons through the metal wire. And now I'm going to follow this circuit diagram to connect the wires to the battery, the light bulb, and the switch. Now we're going to start with the battery. We're going to connect the battery first to the switch by using this wire. I'm going to connect the battery to this wire, and that wire is going to connect to the switch. And I'll tighten this using the screwdriver. Then I'll come out of the other end of the switch with a new wire, tighten that down with the screwdriver, and now go into the light bulb. Using a wire nut, we connect that wire to the light bulb, and then another wire nut to go to the wire that comes out of the light bulb. And finally, we go back to the battery with the last wire nut. Now we have a wire going from the battery to the switch, from the switch to the light bulb, and then back to the battery again. We call this a complete circuit, since the electricity can follow a complete path that starts at one end of the battery and ends at the other. That explains why an electric plug has two prongs. In order to complete the circuit, the electricity comes in one prong and goes out the other. The two prongs are like the two ends of the battery. But you might wonder, how does the switch work? When the switch is turned off, it disconnects the wire, so the electricity can't get through. And then we no longer have a complete path for the electrons to follow. But when the switch is turned on, it connects the wire and the electricity can flow through this now complete circuit.
I get it now. A plug has two prongs to form a complete circuit.
Yeah, the electrons need a complete path to move from negative to positive.
See, I told you we should have used one of our lab lines earlier.
Well, there's only one question left and one lab line. But I mean, come on, between the two of us, we can think of some way to conserve energy.
Yeah, but I don't know what conserve means.
Conserve. To use something carefully in order to prevent loss or waste.
Thanks. I still don't know how we can conserve electricity using this rope, though.
Well, let's think of some things we can do with this rope.
We could use it as a jump rope, or lasso some cattle.
Yeah, or use it as a clothesline.
Wait, that's it. You can conserve electricity by drying your clothes on a clothesline instead of putting them in the dryer.
Yes!
Congratulations! You've completed your task. Let's review. What is the difference between static electricity and current electricity?
Static electricity is when uncontrolled electrons pass from one body to another, like getting a shock after walking across a carpet and touching something.
Current electricity is when the electrons are controlled and move in one direction,
Like movement along a wire, which is how electricity moves from a power plant to your house.
Why do electrical plugs have two prongs?
To form a complete circuit.
And last, but certainly not least, how do we conserve electricity?
Dry your clothes outside on a clothesline instead of a dryer.
or turn out the lights whenever you leave a room.
Or unplug your computer, phone, or any other electronic devices when you're not using them.
All excellent suggestions. You've done well, scientists.
Yes. So do you think you'll be back for another challenge?
I wouldn't miss it. Between you and me, Fashion Club was never this exciting.